Hi, everyone, and welcome to NextGenInfra.io. As AI workloads are outgrowing the physical and power limits of a single data center, there's an increased demand, of course, to scale the compute infrastructure across multiple facilities. This shift places new demands on the interconnect fabric. Broadcom is just announcing that they're shipping the latest generation of Jericho, the Jericho4, the latest in its line of Ethernet fabric routers, which is specifically designed to address this interconnect challenge. So, among the interesting things with this announcement, at least for me, I found what was a 3.2 terabit per second hyperport, stitching together the capacity of four 800 gig ports. So I'm definitely interested in hearing more about that today. So it's my pleasure today to be speaking with Hasan Siraj from Broadcom's core switching group to better understand the technical directions of Jericho4. Hasan, welcome.
Thank you, Jim, and thank you for having me today.
So Hasan, could you tell us first, what are the interconnect challenges that are arising now that the AI workloads are scaling to such an extent, and we have this need of interconnecting multiple hyperscale data centers?
Definitely, Jim. And so, if you just look back over the last 3 or 4 years, what has happened is these large language models, like people have been trying to train these models, and it's a distributed computing problem, which means that these models they cannot sit in a single XPU. Um, I mean, which has tons of thousands of cores. You need actually hundreds or thousands of these XPUs or GPUs to train such models.
Okay, let's dig into each of those a little bit more, all of the parameters for performance there. So, one of them, of course, is that capacity. And the optical industry is moving as quickly as it can to move to 1.6 and 3.2 terabit per second. But obviously, that's not ready yet. But here, you guys are introducing something you call the hyperport. What is it, and how does it work?
The 3.2 terabyte hyperport concept, first of all, on Jericho4, we support 32,000 3.2 terabit ports. And you've heard about the 1.6 terabit port that we now support with Tomahawk 6, but hyperport is a new concept. The question really is, why is this needed and why is this essential? And this is because when you are going across data centers, and if you were using four 800 gig links, now we can actually combine these four 800 gig links into a single 3.2 terabit link. And why is this required? Because if you are going across four 800 gig links, what will happen is the flows going across, it can result in hash collisions, which does not result in very good link utilization. Additionally, if you have one very large flow, like a 600 gig flow, it's going to just map to one of the 800 gig links. And again, your utilization is going to be not optimal because now not you're not using three other ports. But with the hyperport, we really extend the concept of perfect load balancing that we had in Jericho um, to hyperport, where you're going across data centers. So now you start spraying packets across these four ports. We reorder the packet on the other end of the link because we have reorder buffers in place. And this ensures that you have the best utilization when you're going across data centers.
I
Um,
see.
the tests
So,
that we have seen, yeah,
yeah, so these are like large flows or elephant flows, right? Is that so? It ends up being an RDMA over converged Ethernet, RoCE.
these are absolutely rocky flows, right? This is rocky transport across data centers that's happening. And uh, what hyperport achieves, it gives you this 70% better utilization compared to using four individual ports, for example. And that eventually for the end user results in much better job completion time, right? And which is the
Okay,
end goal when you're building this very large infrastructure.
okay, and I see from your news announcement that there is the claim of lossless RoCE over 100 kilometers. So tell us about that. How is that achieved? It's the buffers.
Uh, Absolutely, right? So deep buffers that are inherent in the Jericho architecture play a key role, right? When you're going across data centers, you're going very long distances. You want to extend the losslessness of the fabric across data centers, and this is what this allows us to achieve. Because if you don't have this capability, what you'll have is you'll have PFCs coming back from one data center to another, and that's going to slow down the overall network. But the debuffers that are available in the Jericho4 architecture allows you to go across very large distances and extend this lossless fabric.
Interesting. So, Hassan, in your opening comments, you mentioned security as another one of the performance metrics or design um, goals. And in these types of networks, MACsec is commonly used. And so, how is it used in the Jericho 4? And how are you able to achieve it over so many ports without impacting the performance that you just mentioned?
Yeah, and this is where it's very important that this MACsec capability, it happens at lines rate. It's completely integrated in the chip itself, and that is what we have done. And we do support MACsec at line rate for all ports on the Jericho family. And again, going across data centers, you're going across your own domain.
Excellent. Good to see the Jericho line continue its legacy and scale up for this new challenge. So, Hassan, thank you very much for joining us today.